Welcome to Chapter 11. This chapter is on subnetting. Subnetting is the most difficult concept to master concerning networking fundamentals. Subnetting means taking a single IP range and creating two or more subnetworks from it. To do this, you must master binary to decimal conversion and decimal to binary conversion. The term mastery means complete understanding and ability to use and apply a concept, not simply becoming familiar with it. A simple familiarity is not sufficient. Without fully understanding binary counting and conversion to decimal, the following information is difficult to understand and impossible to apply in the field. Digital electronics consists of circuits that have only two electrical states, on and off. The binary number system consists entirely of ones and zeros. The ones typically represent electrical energy, and the zero typically represents the absence of electrical energy. Digital circuit patterns can be represented by binary bit patterns. The major problem with the binary number system is reading and interpreting the numeric values of the binary bit patterns. We're used to the decimal system, and our minds are trained to interpret and do calculations based on decimal numbers. In addition, decimal numbers require much less space than binary numbers when written out. You can see the place value columns in binaries. In decimal, we have ones, tens, hundreds, thousands, etc. In binary, we have 1s, 2s, 4s, 8s, 16s, 32s, 64s, and 128s. To convert a binary number to decimal, you simply insert the decimal value in each bit position represented by a 1. For instance, you see the binary columns, the 1, 2, 4, 8, 16, 32. We're only going to go at that far. If you have a 1 in the 32 column, you put a 32. You have a 1 in the 8s column, you put an 8. You have a 1 in the 4s column, put a 4. You have a 1 in the 1s column, you put a 1. 1 plus 4 is 5. 5 plus 8 is 13. 13 plus 32 is 45. The IP version 4 address numeric values are encountered in computer technology and are displayed in decimal form, not binary. This form is referred to as dotted decimal notation. So each of the binary numbers is converted decimal before we actually write it out. So dotted decimal number would be something like 128.143.137.144. You should recall that a subnet mask serves to identify the class of an IP version 4 network and to allow the network address to be divided into subnetworks. Dividing a network into subnetworks or subnets is called subnetting. Router technology also relies on subnetting for creating large sections of network communication paths. That is basically a shortened form of the term subnetwork. A subnetwork that doesn't divide into any smaller subdivisions is considered a single broadcast domain. In other words, when a computer or device broadcasts, it doesn't go beyond that subnet. Subnets have a beginning and ending address, and the beginning address is always an even number. The ending address is always an odd number. The beginning address is considered the network ID. The ending address is the broadcast ID. You are not allowed to use the network ID or broadcast ID as a host address on the subnet. To refer to a subnet, you would use its network ID and its subnet mask. The subnet mask defines its size. So you would say something like 192.168.1.0, that's the network ID, 255.255.255.0, that's the subnet mask. A popular size for a subnet is 8 bits, which is 1 octet. So the 255.255.255.0 is a classic Class C. It, as an 8-bit subnet, contains 256 hosts, but the first and last are reserved for network ID and broadcast ID. So really, you only have 254 usable IP addresses in that example network. And you cannot arbitrarily pick the beginning and ending of a subnet. The division has to be along clean binary divisions. So you can see by this example where the green ones are good, clean divisions, and the red ones do not work. The subnet mask defines the size of a subnet. 8 numbers keep reoccurring in subnet mask. They are 255, 254, 252, 248, 240, 224, 192, and 128. Those repeat over and over for each class of network to subdivide it. As you can see here in the column that says maximum host, that's how many hosts, total hosts, you could have on that network. So for instance, if the host bit is length 2, you have something as subnet mask that says 255.255.255.252. That gives you 4 total hosts, but the network ID, the broadcast ID are both reserved. So that would actually give you 2 usable addresses on that network. The subnet mask is called a mask because it can also help you pinpoint the endpoints on a subnet if you're given any IP address on that subnet. It masks out all the host bits, leaving only the network ID. For instance, given a host with an IP of 10.20.237.15, that's a random computer on the network, and a subnet mask of 255.255.248.0, you can find the network ID by using the logical function AND as follows. In binary, when you do the AND function, you basically, anything that is not a 1 and a 1 becomes a 0. So if you do that mathematic across, you're going to find out that anything that's a 255 is all 1s, so it's all going to drop straight down. So the first 2 numbers are 10.20. In that third octet, you find it starts becoming zeros in the bottom. Anywhere there's a 1 and a 0 or a 0 and a 0 becomes a 0. So when you get through to the end, you find all zeros, that becomes simply a 0. That third octet then becomes a 232 once you do the and calculate what that binary number is. So the network ID ends up being 10.20.232.0 with 255.255.248.0 as the subnet mask, which gives us 2,048 possible hosts. The graphic there at the bottom shows you the one computer that we had the IP for, but the orange area shows us the entire subnet range. There are advantages to subnetting. A subnet allows a single shared network address to be split up into many smaller networks. Without subnets, organizations require lots of network addresses, and we have a limited number of network addresses available. It alleviates traffic. It allows for smaller routing tables. It allows for smaller collision or broadcast domains, so it allows for fewer collisions and congestion. It's easier to manage and solve problems because your problems generally happen on a smaller size network. And there's better security because you can separate departments from other departments. There are some disadvantages. Often subnet addresses aren't allocated proportionally per subnet. They're limited by the number of IP addresses. You have to buy routers to talk between subnets. And if you have to do a whole lot of binary math, it can be confusing. Now, there are devices that segment networks. Those devices include switches, routers, and bridges. This diagram here is what I consider each one as. A router is basically a gateway between networks. So you have routers per network. Switches are generally, like a concentration of network connections. Then you have the hosts as computers. And a bridge would basically be down where you would have multiple computers in one location, bridged to another location, all tied into the same switch. Classless inter-domain routing. Classless inter-domain routing uses special notation to represent the subnet mask. So instead of writing 255.255.255.0 every time you want to discuss a subnet mask, it would use a slash between the network ID and the value that represents the length of the ones in the subnet mask. So if you have a 255.255.255.0, every 255 is 8 ones. If you add up all the ones in 255.255.255.0, you come up with 24 ones and 8 zeros. So that would, the CIDR expression of that would be something like 192.168.1.0/24, meaning 24 bits of the address represent ones, and the last 8 represent the host. The CIDR correlates to the IP version 4 address by assuming each portion or octet of the IPv4 address represents a maximum value of 8 bits. To configure the CIDR, you simply think of each part of the IPv4 address as having a value of 8 bits. For example, to figure out the CIDR for a network address 192.168.123, you would add together 3 values of 8. 8 plus 8 plus 8 equals 24. So you can see the standard class A has 8, the standard class B has 16, standard class C is 124. If you break the class C down into smaller and smaller subnetworks, you have to do it in that order: /25, /26, /27, /28, /29, /30. And this time, remember to keep calm and practice subnetting.